recording. Alright guys, this is going to be a piston coil, and this is going to be low superheat. So what I want to know is, we're going to take it from the return air all the way to the supply air, and we're going to take pressures, temperatures, refrigerant, all this kind of stuff. And I want to know as many things as we possibly can that will give you a low superheat. So here's where we're going to start. This is a piston coil, and then we're going to start with a low superheat. First of all, if you have too much refrigerant in the system, that's going to give you a low superheat, because too much refrigerant running through that evaporator coil is not going to pick up the heat from the evaporator coil. If you have a dirty filter, it blocks airflow through the system. So when I say low superheat, a lot of times what you have to think about is what is going to cause low airflow through the system. You remember me telling you that? If anything causes low airflow or a blockage of airflow, that is going to cause a low superheat with a piston coil. Now we're going to get into expansion valves in a minute, but this is all with a piston coil. So if you got a dirty filter, blocks the airflow through. Go to your return grill. If your return grill is too small, you're not getting enough airflow through the system, so your static pressure really increases on that system and restricts the amount of airflow going through that system. If you have any types of obstructions on the filter grill, so if the couch is backed up against the return grill, that's going to cause a restriction of airflow through the system. Obstructions inside the return chase. So if you look inside that return chase and a piece of sheetrock falls over, or a piece of ductboard falls over, and that's going to block that airflow running through that system. You continue to go past that, and your return chase is too small. So you may look into the top plate, and there may be a 2x8 or a piece of 2x2 plywood blocking off half of the return chase, and a little bitty small plenum at the very top of that chase blocking it off. We've seen it a dozen times. So don't assume that when you stick your head in that return air that everything's going to be fine from the floor all the way to the top. A lot of times it's restricted, or sometimes you can actually see the attic up there that the return plenum is not as big as the return chase is. Okay, and that will get into a high superheat on that part. Here we're working on low superheat. So if your return chase is too small, you look at the filter grill on the wall, and the filter grill is a 24 by 24 with a 3-ton system, and that's fine. Because height time width time 2, 24 by 24 gives you 1156 CFMs of airflow for your return. Height time width time 2, write that down and remember that. That is your return grill size. Height time width times 2 gives you the CFMs for your return air. So 24 times 24 times 2 totals out to 1156 if I am not mistaken. Okay? If you got a 20 by 20, 20 times 20 is 400 times 2 is 800. So a 20 by 20 is 800 CFMs. That's a 2-ton air conditioning system. Every air conditioning system is 400 CFMs per ton on your air conditioning. Now your return air is going to run a negative 0.03 static pressure, and your supply air by itself would run a positive 0.8 static pressure. Therefore, the two combined, positive 8 and negative 3, gives you a 0.5 static pressure on your system. With this being said, all air conditions are designed, all normal air conditions for residential homes are designed at a 0.5 static pressure overall in the system. And when I say overall in the system, I'm saying your return and your supply. If you take a Magna-Healy gauge or an inclinometer and you only check the return static pressure and you come up with that number, and then you go to the supply and you take that number, and whatever it comes up with, you may have a 2.0 static pressure inside your supply plenum. That's an extremely high static pressure. That would be an indication of not enough ductwork. If you have a very, very, very high static pressure inside your return, like a dirty filter or too small of a filter grill, or your chase is too small, that blower motor sucking extremely hard trying to get that airflow through. So instead of a negative 0.03, you may have a negative 9, 10, or whatever may be the case. that gives you a really high static pressure in your return. That tells you return air is blocked up. Okay, so we're going to do a class on magnehelic gauges and incline manometers to put this to real life as well. Okay, let's continue this down. Return chase too small, a blocked return. Stick your head inside that return, look up to the very top, and that return plenum should be the size of the chase. I was getting to the point where your return grill as well. If that return grill on your wall is 24 by 24 and you never go and open it up and stick your head in it, it may be only 4 inches deep. And that's not good. If you got a 4-inch deep and 12-inch wide return chase or 24-inch wide return chase and only 4 inches deep, you're not getting enough return air through that system. You really and truly want to have at least a 20 by 20 for maybe a 3-ton system chase up, or 24 by 24, 4 square feet up in that return chase to bring that airflow coming up all the way through. Okay? If you get a 5-ton system, your return grill size should be at minimum 24 by 36. And that still doesn't give you a full 5 tons. You may have to do a 12 by 12 dedicated return coming from a master suite or something like that to get the full airflow through. Okay? So let's go up through that system. If you have transitions or return plenums that are blocked up, so the insulation inside that return or the insulation inside the transition falls over and blocks that return air, that's going to cause a low superheat on a piston coil. If your filter rack is dirty, so the filter inside that filter rack, so a lot of times on a horizontal system you have a filter rack before it hits the heater. So if your transition is built too small, a lot of times the physical size of the heater itself may be 28 wide by 20 high, and you see that transition come back down to 11 by 20. Well, that hole where it comes from at that return plenum is too small. It's blocked off. So when that happens, you're restricting airflow through that system. You take a magnehelic gauge or an incline manometer, take your static pressure here, take it here, there's going to be a difference because the airflow is trying to get through and it's being restricted through that hole. It's too small. So always check your return plenums. Your return plenums a lot of times are too small. Your filter grill, I guarantee you, if you do height time, width time too, I'm telling you, you'll probably find 98% of the time your filter grill is too small. One of the things we didn't mention, we said dirty filter. You know what we didn't say? A electrostatic filter. They're real thick filters. Okay? People they'll buy those really allergy-free filters that are really thick. Now what that did was it restricted the airflow through the system. Those filters are fine, but you better increase the size of your filter grill. So look at it this way. If you've got a filter grill that's this big, then it can allow a lot of airflow through. So let's just take your original 20 by 20 return filter grill that you were putting a filter in that you could read a newspaper through, one of the little fiberglass ones, and it was working fine. Then you go buy one of those 1-inch thick filters that you can't see through, you can't hardly blow through, and you stick that in there. When you stick that filter grill in, a filter inside that filter rack, it goes, sucks inside there. When that happens, that return air sucking in there, you're restricting airflow through that system. So that's going to cause a low superheat. So add your allergy-free filters in here, because that is definitely a problem. We see that a lot. So allergy-free filters. There's nothing wrong with those allergy-free filters if your return air grill is large enough to allow the airflow through. One of the reasons that you want to run a 0.0 static pressure, negative 0.03 static pressure inside your return is because you want your airflow to move at, let's just call it, instead of 100 miles an hour, you want it to move at 30 miles an hour. So if that air passing through that filter runs through slow, the filter can catch all the debris inside of it. If it runs through at 100 miles an hour, it'll pass right through with no problem, okay, because it's being sucked through. But if the airflow inside that return passes through very slowly, then the filter is going to catch everything running through. Remember that, because that's a big point, okay? Your transition is too small up in the attic, so we talked about that. If that transition comes down to a point, you have to look at the transitions, because a lot of times they take an existing hole that was there from another furnace, another return plenum and they put a new heater in, and they'll transition to the existing hole instead of making that hole bigger to fit the new furnace. How about if you go from a 3-ton to a 4-ton system in your house, and the existing return grill is a 20 by 20 and you put a 4-ton system in it? I went to one today. They had 2 9s and 4 7-inch ducts in the attic, and they had a 20 by 20 return and a 4-ton system. So if you think about it, I'm going to tell you the numbers off the top of my head. 9-inch duct at a 0.8 static pressure gives you 250 CFMs. 2 9s gives you 500 CFMs. 7-inch duct is 110 CFM. So 4 times 110, that's 500 plus 440 gives you 940 CFMs. They have a 4-ton system inside that house with a 20 by 20 return grill, and they're trying to push 1,600 CFMs of airflow through that system. There's no possible way it's going to work. Okay? So I sold it, and the house wasn't but about 1,200 square feet, so I sold her a 3-ton air conditioning system. And I enlarged the return grill to 24 by 24. So now we can get more airflow through that system as far as that's concerned. We can run it at a higher static pressure. She still needs a little bit more ductwork in there as well to push through those rooms up. But that 4-ton system doesn't have a chance. Okay? Your filter rack with a dirty filter inside of it, a lot of times that filter rack before the heater, they don't even know that filter's there half the time. So anytime you see a filter rack in a horizontal application, you better go open it, because what you're going to find is a filter that's been blown through and ripped apart because it's so dirty and that blower motor is sucking that airflow through that finally it ended up weathering that paper down and blew holes in it, so your filter being pleated is going to open up and blow that air right on through, and all the dirt and everything's going to get all in your blower motor. Okay? So also, if you have a filter inside your heater, a lot of times you put a heater in, there's a filter that comes with the system, you leave that filter in there, nobody ever knows it's in there. It's in there for 20 years. You're servicing the air conditioning, you're servicing the heater, and nobody opens the blower compartment and looks to see there's a filter in there that's blocking the airflow through. A lot of times when I put a unit underneath the house years ago, when it was still code that you could do that, I would always leave that filter inside that heater, because if it's underneath the house, there's a return grill on your floor, and that return plenum gets full of trash and dirt and dog hair and all that kind of stuff, and they're never going to change their filters there. So all that stuff keeps falling in there, so I left the heater filter inside of it, the original one, and they'd call me out once or twice a year, or whatever may be the case. It wasn't cool, and I'd go out there and I'd pull that filter out, clean the filter out, put it all back together. I'd tell them the filter's down there again, but nobody would ever go and change it. But if I pulled that filter out, the blower wheel would be filthy dirty, the coil would be filthy dirty, and it would cost them $600–700 to clean all this stuff, instead of $100 for me to go out there and pull the filter out and clean it. Big difference, okay? I help the customer out by leaving that filter in there. Insulation sucked into the blower wheel. So you got a horizontal unit in the attic or a vertical one in a closet. If you open up your blower door and you see insulation sucked into the blower wheel, it's restricting airflow through the system, causing what? Low superheat on a piston coil. Okay? If your blower speed is too slow, you need 1,600 CFMs of airflow for a 4-ton system, 1,200 CFMs of airflow for a 3-ton system, 400 CFMs per ton. 5-ton system, 2,000. 3.5-ton system is how much, Adam?
3.5 ton, 4 times 3, 12, 14.
1,400 CFMs, you got it, okay? How about a 2-ton system, Mike?
800.
800. 2.5-ton.
1,200.
1,000. Okay? 400 CFMs per ton. Okay? Based on a 0.5 static pressure. Now, if you have what's called the Unico system, the Unico system is a high-pressure duct system. That might run a 3.0 static pressure inside the system. A mobile home unit will run a 3.0 static pressure inside that system. Every duct they run is a 6-inch duct running through it. So if there is a 4-ton system in that trailer, there is 16 ducts running in that system. We're giving a class and I'm on film right now. I'm starting it already. I'm rolling with it. If you want to come, come on. If not, I got it on film. Whoop. All right.
Just edit that out.
Yeah.
Yeah.
Yeah, I can edit that part out. Yeah. Shit. Yeah.